Welcome everybody to my session on developing Java application with Visual Studio Code. My name is Fred Bricon. I'm a principal software engineer at Red Hat Developer Tools. I have a background in Eclipse plugin development, and I'm really used to working with Eclipse. I've been working with JBoss tools. I'm a committer and project lead on several Maven-related plugins at the Eclipse Foundation. And lately, I've been working on a couple new projects, the Eclipse JDT LS project and the Red Hat vscode for Java as a code project lead. I'm also contributing to another similar project for a language server for XML and an extension for XML in Visual Studio Code. And today, I'm gonna try to give you a taste of what it's like to develop Java applications in Visual Studio Code, which is not necessarily something that you can think would be natural for a Java developer to do. So I'm going to go back a little higher in a stack and explain what exactly is Visual Studio Code and what the language server protocol is. These are the foundation of the tooling that we're going to demonstrate later today. And more specifically, I'm going to talk about how we made it happen with the Eclipse JDT LS, the Java language server, and the VS Code Java extension. And I will also talk a little bit about the Java ecosystem that exists today in Visual Studio Code, in the Visual Studio Code marketplace. And most of the demonstration today will be live coding. And finally, we'll see what's coming next in the future releases. So, Visual Studio Code is defines itself as a lightweight, extensible source code editor. It's open source, developed by Microsoft, but is driven by a vibrant community. The project itself is led by Eric Gamma. If you don't know who Eric Gamma is, he's a member of the Gang of Four, wrote the design pattern book. And he also is known for developing the Eclipse JDT project. So he basically wrote Eclipse back in the day. So he and his team were now working for Microsoft, knows something about IDEs. And the principle of Visual Studio Code is that basically all the smartness that the tool provides in terms of code completion for any language, analysis, validation, linter, everything is delegated to something called language servers. So the concept of language server, before I dive into language servers, if we look at the spectrum between text editors on one side and IDEs on the other side, a text editor will allow you to edit files, edit code, maybe search and replace. And on the other side of the spectrum, the IDE will provide ways to run applications, provide wizards. And Visual Studio Code in that spectrum is probably something somewhere in between, but closer to a text editor. It's lightweight, very fast, and everybody loves it. So the language server protocol, if we look at the definition on the website of the protocol, we can see that a language server itself is meant to provide the language-specific smarts and communicate with development tools over a protocol that enables inter-process communication. So the idea behind the language server protocol is to standardize the protocol for how such servers and development tools communicate. So this way, a single language server can be reused in multiple development tools, which in turn can support multiple languages with minimal effort. So that means if you're developing a new language, you probably have the skills to work on the language itself with how to provide validation on that language, make it compile if needed, But you don't necessarily have the skills to provide integration with all the editors or IDEs that exist out there. So if, as a language developer, you provide a language server protocol implementation, that means all the other tools out there that implement the same protocol will be able to use your tools with minimal effort. Similarly, if you're a tool vendor, an editor, you don't necessarily have the skills to provide good integration for all the new languages that exist elsewhere. But if you provide a common ground for everyone to communicate in a similar fashion, then it makes it much more easy to integrate all the new languages, all the new features that soon exist. So the protocol itself defines standard messages for completion, diagnostics, and so on and so forth. It's client and implementation agnostic. That means the protocol itself does not know who's going to run, and there's no the server that implements the protocol can be implemented with Java, Python, C#, you name it. As long as the messages follow the JSON RPC2 standard and follow the protocol that's been defined. So the protocol development is led by Microsoft. It's open source. And you can see a couple links where you can find some more information on that protocol. So in a nutshell, the way it works is you have the tool on one side, so that would be your IDE or your editor, and the language server, which is a process that runs locally next to your editor. So as a user, you're interacting with the tool. So the user opens a document, and then a message is sent to the language server to open that basically says, I opened a document. So the server initializes its state, several tools, whatever, and then the user can then edit the document. And as soon as something changed in the document, the language server will get the event, and then will calculate diagnostics, for instance, and then will emit a series of events to the client to, for instance, publish diagnostics. So if you made a compilation error, the server will send that information to the tool, to the IDE, and the tool will display the errors. So all that constitutes the language server protocol as a JSON RPC mechanism. Now, for Java development, we've implemented a language server for Java, written in Java, that follows most of the language server protocol specification. It's called Eclipse JDT LS, and it's built on top of the Eclipse platform and several other projects at the Eclipse Foundation. So basically, when you're running the Java language server, you're running a headless Eclipse instance behind the scenes. So everything depends on Eclipse eventually. The server itself, the project itself is open source, licensed under the EPL 1. And most of the contributors are coming from Red Hat, Microsoft, and Typefox and IBM, and some other independent developers. So as I said, it implements most of the language server protocol features, but it also adds custom commands. So for instance, if you want to add a command that says, compile the workspace, compile all the Java classes, this is not defined as a common standard message in the language server protocol. So we've added several custom commands like that. The server itself is extensible through OSGI bundles. So because the server is based on the Eclipse platform, we can leverage the OSGI mechanism to load external extensions to the server itself. So you can contribute debuggers, decompilers, or additional commands to extend and improve the server depending on your needs. It's a rather lightweight distribution, weighs under 40 megabytes. Eventually, you can probably make it even lighter, but it will require some work. And it's a server that's been adopted by many clients today. So we'll talk about Visual Studio Code today, but it's also been adopted by Eclipse J, Eclipse Thea. We have several adoptions from Vim and Emacs projects, Atom as well. So it's become an ubiquitous language server for Java. So if we talk about VS Code itself, Red Hat has developed the VS Code Java extension, which is a really thin wrapper around the Eclipse Java language server. So the extension itself doesn't do much. It just starts the server process and then delegates everything to the server. We released the first version about 2 years ago in 2016, and we release about twice a month, except once a month during summer and Christmas. As of now, the previous version, we had about 500,000 installations, so we know that at least 500,000 people are using our extension or installed it once at least. And if we look at the cumulative number of installs over time for the past 2 years and change, we are currently, as of now, at about 8,700,000, which is a pretty big number. So the extension ranks I think in the top 10 of the Visual Studio Code marketplace. So this extension will be downloaded by default if you open the Java file in Visual Studio Code. Now, because the server itself is extensible, as I mentioned, we saw several Visual Studio Code extensions leveraging that extensibility factor. So we have the ecosystem itself, of course, contains the VS Code Java extension, but we have a Java debugger provided by Microsoft, Maven support, and a test runner check style support, also contributed by Microsoft Teams. Red Hat also provides a brand new extension to analyze your Maven dependencies. It's called Fabricate Analytics. Maybe we'll take a look at that later. Pivotal provides Spring Boot support, which is pretty neat. Unfortunately, it doesn't work very well on my machine, so we won't see that today. There's a Java decompiler, Lombok support, and many more extensions, Camel or many others. All right, so now that I've laid the foundation of this talk, hopefully you understand the principles of how it works. So we're going to do a little demo. So I'm going to jump into command line and create a brand new hello Java file. Oops. All right, so I'm going to make it full screen. All right, can you see? All right, so I got a new Java file. Right now, there's no Java support. I need to save the file for the server to kick in and to know that it will be able to read the file and do some diagnostic and whatnot. So if I save the file, the server will tell me that the class path is incomplete and only syntax error will be reported. That means that that file can be a single file, but it also can be a file that's part of a larger project, and I don't have the server doesn't have all the information necessary to compute all the dependencies, the type dependencies, and cannot provide accurate information about the type system and compilation errors, basically. So if I were to display full compilation errors, on any given random file, then all my files will be filled with red errors all over the place. So I got that warning from the server. You might have seen it if you've been using vscode Java. So for now, I'm going to shut that down. And I'm going to create a new class structure. So as soon as I type, I got some autocompletion. So I got a choice of using two class completions. One is just a class keyword, and another one is a class snippet. Because the snippet is fairly smart, it understands that it needs to create a class called hello, because that's hello Java is the name of the file. So I'm going to create a min method. So again, I've got autocompletion, and I'm going to display just hello world. All right, sysout is a shortcut for system out println, hello world. And as you can see here, I have a couple links in Visual Studio Code lingo. They're called code lenses. So I've got two code lenses, one to run the app, the program, and another to debug it. So I'm going to run it. So I'm going to save the file, run it. Hopefully. And it fails to run because the debugger requires me to open the file in a folder, not a single file. So I'm going to reopen the file. Close window. Code. All right, so I'm back to opening my file. Let's get rid of that, please. Ouch. There. Don't show again. All right, let's try to run it now. Hello world, everything works as expected. So I simply open a Java file and run it, and that's it. I did not compile anything. I did not do any build step. Everything just works out of the box. So the way it works is that the Java language server based on the Eclipse platform provides an incremental compiler. So every time I change something in my Java source file, as soon as the file is saved, it's automatically recompiled, which is pretty neat if you work on larger projects. So at that point, this is a simple Java file. I have no class path context, so I can't. If I say foo equals null, I don't know whether the foo type exists or not, so the server won't report an error. However, I got minimal syntax error reporting. So here, if I miss a semicolon, I can see the error that's reported here. So I got minimal Java support, but still, I'm able to do things such as extract a local variable, and I can rename that variable with F2. I can name it greeting, and it just works. So I got maybe half of the Java support. So for a simple Java file editing, that's pretty nice. Okay, next step would be to do some debugging. So let's see. If I put a breakpoint and run debug, obviously I expect the breakpoint to be hit. I can see the local variable greeting, and I can even change it. Hello, code 1. Enter, and then release the breakpoint. And I want to see the debug console. And there you go. So that's fairly advanced for simply editing a single Java file. So next step is to see what happens for larger, more complex projects. So I'm going to kill that, and I'm going to open a Spring Boot application. Code. So this application is based off of Spring Boot, and it's a Maven project. Let's see, that is probably too big. So it's a Maven project. Well, as soon as I open the folder that contains the POM.xml, the server will detect that it's a Maven project and will then configure the Eclipse. The server will configure the Eclipse workspace behind the scenes to convert all the Maven configuration into something Eclipse, the underlying platform running the server, something that Eclipse understands. So you will be able to see files appear like a .project, or for Java projects, .class path, .settings. If you're used to using Eclipse, you will recognize those files easily. But if you're, for some reason you don't like them, there's a way to get rid of them somehow, to hide them. So you would open the preferences, settings. I'm going to open the settings JSON, my workspace settings. So the workspace settings exist under the .vscode folder here. All right, and you can define a files.exclude preference to hide all the files you don't want to see. All right, so as soon as I save, go back here, I don't see those .project file, .eclipse related files anymore. So this is a good tip to know if you're bothered by those Eclipse files in VS Code. So let's take a look at the project itself. So it's a multi-module application. There's a to-do app that contains a controller. Well, it's a to-do application itself, a Spring application that runs itself, the class. There's a couple controllers, and there's another project, to-do model, that just contains a model, one model class. Okay, so I can navigate through the Explorer here, and if you look below, there's a Java dependencies view that's provided by a new extension that was released a few days ago. It's called Java Dependencies, published by Microsoft. That gives you a way to navigate through your project like in a package explorer view in the Eclipse land. So you can see through the packages, you can see the Maven dependencies. So model doesn't have anything, but to-do app has more dependencies, it's more interesting. So if I open anything, open a class, I can see that the class, the .class file has some sources available. So what happens is, as soon as I open my Maven project, the server behind the scenes will download all the sources if they are available, and will attach the sources to those dependencies. So that makes it very easy to get documentation on anything you use in VS Code. You don't have to do anything. Everything works just out of the box. All right, so we have this to-do application. As you can see, I got a main method, so I can run that app. So I'm going to debug it. All right, so I switch to the debug view. I can see the call stack. There's a bunch of threads running through Spring Boot. it seems that the application is running. I don't see any errors. So I'm going to look at the, I'm going to open the application in the browser. All right, so I'm going to refresh that for 9090. I can see a list of to-dos. Pretty cool. Okay, so I can select what's done, clear what's completed, and there you go. So what can I do next? Well, I mentioned navigation, but you can also see there are other ways to navigate through the application. So let's go back to the Explorer view. I can navigate within a file using what's called the outline. So that would be Command-Shift-O. And I can see that within the context of my file, I can navigate through the different elements. So the attributes, methods, and whatnot. I can navigate within the project with among all the files from my project by hitting Command-P. And that will open a list of all the files that exist in my project. So if I want to go in the to-do Java class, then that's all I have to do. I have, of course, Hover, documentation on Hover with a pretty nice Java doc with markdown rendering. I can navigate through classes in my project class path. So I just Command-click or Control-click on Windows and Linux. And then I navigate through the source of my class. And I can even navigate through anywhere in the from the Java doc to any place. Okay, let's take a look at the errors. I can see some warnings here. So here I have, let's see, let's hide that. I got a bunch of unused imports. So one way to fix that is to organize imports. So I got one menu here. I can organize imports or through the Alt-Shift-O command. And the warnings are gone. So I can save the file. But if I don't want to do that manually all the time, another option would be to enable auto organize imports on save. So I would go to the settings. Let's go back to my settings, JSON, workspace settings, and organize imports. I'm going to put it to true, lowercase. All right, so going back. Where do I have some warnings? Here, I just save the file, and it's automatically auto-imported. All right, but I can have more complex errors, like actual compilation errors. So if I say delete that, and I save the file, I instantly see 9 compilation errors. So again, this is leveraging the Eclipse compiler behind the scene. That's an incremental compiler, and that gives me instant feedback on everything I do. I just have to save the file. I don't have to run a command to build my project. Just save it, and boom, you have it. And same thing, as fast as I broke it, I can fix it. So I just need to roll back and save the file. Hopefully, where am I? Save the file, and boom, the errors are gone. Okay, so I got, what else do I have? I have testing. We have testing support with the test runner from Microsoft. So similar to the code lenses for running the app, we have code lenses for running the tests. So if I run the test here, vscode will launch the test runner. And I should see some problems here. One test failed. All right, so I'm going to kill that. Close all. I want to look at the report. So test get missing to do is failing. Expected 200, but it was 404. All right, so let's see. I'm going to look through to-do controller. There. And the problem here is in this test get missing method. So obviously, if the thing I'm looking for is missing, it should not return code 200, but most likely 404. So I can rerun the test. And now I see the proper tick, and the class itself should refresh. Yeah, there you go. So there's test support. So again, I can debug my test. Same thing as I showed you before. So what else can I show you? Let's see, if I have, let's go to the to-do object. So here, I got a simple Pojo with a bunch of attributes and many setters and getters. So first of all, I'm going to show you how you can create those getters and setters. And then we're going to see how we can get rid of them. So I'm going to delete them. And if I want to create a setter for the title, I just type set title, press enter, and that's it. It automatically created my setter for me. And I can do the same thing for the getter, of course, get title. But I can also go through the ID, probably not the ID, completed. Nope. I messed something up. Let's try again with, Oh, okay. So I got an hash code and equals method that use those attributes. So if they were not used, I would have a code action, so like a quick fix that would allow me to create new getters and setters automatically. So I'm going to add a new thing here, and I can see the light bulb here that tells me that I can create getters and setters, and that's it. So I want to get rid of all that clutter. So one way to do it is to use Lombok, which is an annotation processor that does that pretty well. So to add Lombok, first of all, I'm going to delete everything. All right. So I'm going to delete that. I'm going to keep the constructor. I need them. I'm going to delete to-do, hash code equals. And I should see a bunch of compilation errors all over the place, as expected. So what I'm going to do is add Lombok to my project, and then I will add an annotation for Lombok to generate all the getters, accessors into my class directly from vscode without doing much. So to get Lombok support, you need to install, first of all, you need to install the Lombok annotations support in the Visual Studio Code Marketplace. Once you've done that, you can open your POM.xml. So in my case, that will be to-do model. I'm going to get rid of that and that. And I'm going to add a dependency here to Lombok. So I got a template that has the Lombok dependency. So if we look at the Maven support here, it's not basic, but it's not complete yet. So I'm not able to search for dependencies like in IntelliJ, where I would type the group ID or the artifact ID or the version, and it would fetch the proper version automatically. Or at least propose those results directly in the UI. However, we have schema support. So because the POM XML declares the schema to use, we get documentation on hover, we get support for basic XML validation, and all that XML support is provided by another Red Hat extension called just XML. You can find it on the Visual Studio Code Marketplace. It's honestly the best XML support you can find in VS Code today. All right, so anyways, I've added my Lombok dependency to the POM XML. So if I save the file, I can see the build file was modified. You want to synchronize the Java class path configuration. So what that means is I changed the POM, so maybe the Eclipse configuration behind the scenes needs to be synchronized with the changes in my POM. So I can do it automatically with always, or just now, or just ignore the warning altogether. So in the case of adding dependencies, you just need to, you can ignore that. If you were to say, change the Java version that you're used to compile your project, in that case, you would definitely need to update the project configuration. But in our case, if it's just adding a dependency, you don't need to. So once I have added that dependency, I can go back to my to-do class, and I should have a add data. No. Okay, did I save the file? Not this one, the other POM. Model. Okay, let's say now. Anyways, there you go. So the data annotation is now available in the class path of my project. So if I select it, enter, I got automatic import of the type. And I save the file, and then all my compilation errors are gone. Everything is just working now because the Lombok behind the scenes modified the class path, the bytecode generated in the class.class file through the Eclipse compiler. So let's see if I still have my application working. It seems to still be working, so I'm going to add something like, what's next? I need to delete that thing. So one way to do it, so not sure I have time to demonstrate that today, but one thing that's available in Visual Studio Code today is something called Visual Studio Code Live Share. It's an extension, again, that you have to install. And I'm not going to do it now because I don't have time and the network is really spotty. But the idea is that if I want to debug my application, I'm able to share the content of my workspace with someone, up to 50 persons. And they're able to connect to my currently running application, put breakpoints, go step by step through the breakpoints, change the content of the values of all the attributes they meet in during debugging. It's extremely powerful and very impressive. Unfortunately, I don't have time to talk about that today, but I will just fix it myself. So the problem is in to-do helper. And I'm going to just delete that to uppercase. So just save the file. And let's try again. There, I fixed it. I've just changed my file and saved it. And my application is still running. Everything just works. So personally, I find that very impressive. Okay, so one last thing I want to show you before we wrap up is related to POM XML support. So previously I've added Lombok's support, but we have a new dependency analytics extension at Red Hat. It's a little bit buggy still, but what it does is it analyzes your dependencies. So I'm going to add a new one. I'm going to add this one, common collections. If you remember, a year or so ago, or 2 years ago, this dependency had commands collection was in the news because there was a known vulnerability with regard to serialization. So if you add that to your project, then you're in danger, so to speak. So if I save my POM XML, I can see an error now. So let's see the error. So the component analysis extension tells me that commands collections 321 is vulnerable with a bunch of CVEs. Okay, so the recommendation is to use version 322 and just change it, and the error's gone. So this is a very, very new extension. It's called Dependency Analytics. If you want to play with it, just go ahead. Just be warned that not all CVEs are reported right now. So if you're using it and expect to have a safe application, by just depending on that, you're fooling yourself. It's not completely ready. Anyways. The license of the extension itself is open source. I'm pretty sure.
Whether you are using a proprietary dependency or
not. Well, it depends. It depends whether the dependency is referenced in the database, CV database by Red Hat. So right now the problem is not all CVs are in the database. So you might be able to add some dependencies, and even though they're vulnerable, they won't be reported. So it's just something to play with at the moment, but it's kind of interesting. All right, so let's go back to our slides. So the sources for this demo are on GitHub. And what's next? So we saw a tiny bit of capabilities that Visual Studio Code offers today in terms of Java support, but we're going to still improve it. We are going to work on improving the refactoring capabilities. Namely, the most important thing for me is the move/rename files when you're renaming type. So you can rename your class, but if you rename the class, the file underneath needs to be renamed as well. Or if you move the file, same thing. And we need to support that. So this has been added to the language server protocol fairly recently, a few weeks ago. And hopefully, I hope before the end of the year, we'll have support for that in vscode Java. We're also currently working on providing quick fixes from the problems view directly. So right now, when you saw me using the light bulbs, I was editing the Java source files directly, but we will be able to do the same thing directly from the problems view. Like in Eclipse, there's a quick fix support in the problems view in Eclipse. And of course, we're going to add some more code actions. So code actions, generally speaking, means refactoring. We're going to work on, obviously, improving the performance. We still have some kind of issues. We're going to add some type hierarchy support. You'll be able to look through all the children of your type or their ancestors. And improving the standalone Java file experience. Right now, it's kind of weird when you're opening a file that exists in a folder with other files, but you don't have, the server does not have those class path informations. So we're going to try to make it more obvious or more user-friendly to work with. And we have a huge backlog to work on, so more things will happen soon. If you want to contribute, I suggest you to go through all those GitHub repositories. All those projects are open source. Please open enhancement requests, bug reports, provide pull requests. You're welcome. And thank you for attending. So if you have questions, I don't think we have time right now, but you can talk to me in a hallway. Thank you very much.